Welcome to this video on transverse and longitudinal waves. Waves come in two types, transverse and longitudinal. The particles in a transverse wave vibrate perpendicular or at right angles to the direction of propagation. Here is an example. You can see this from the motion of the red dot in the wave. Each particle is only moving up and down, i.e., perpendicular to the collective wave motion to the right. The pressure and density of the wave is kept constant. Common examples of transverse waves are all the waves in the electromagnetic spectrum. This shows that transverse waves can travel in a vacuum and have speeds up to the speed of light and have very high frequencies. Also, water waves. You can see here that the particle on the surface of the wave moves up and down, which is in the perpendicular direction to the wave motion as a whole moving to the right. Seismic, S or secondary waves are also transverse waves. Make sure to remember these examples, as they are often asked about in exam questions. The particles in longitudinal wave vibrate parallel to the direction of propagation. You can see this from the motion of the red dot in this wave. Each particle is only moving left and right, i.e., parallel to the collective wave moving to the right. Longitudinal waves vary between areas of high-density particles, called compressions, and a low density of particles, called rarefactions. The fluctuation of these caused the wave to move. The wavelength of a longitudinal wave is the distance between two rarefactions, or two compressions. Make sure to remember these characteristics. You may be asked to label a longitudinal wave diagram. Common examples of longitudinal waves are sound waves, including ultrasound waves, as well as seismic P or primary waves. This is when the ground moves in a back and forth motion. Longitudinal waves commonly travel a lot slower than transverse waves. This is because they require a medium, such as air or water, to travel through, as it is the particles themselves that carry the wave from one point to another. Again, make sure you remember these examples, as they are commonly asked in exam questions. Let's see this in practice. Some waves are longitudinal, some are transverse. Put ticks in the table below to indicate which of these waves are transverse and which are longitudinal for 4 marks. Ultraviolet radiation is a type of electromagnetic radiation. We know that all electromagnetic waves are transverse, so ultraviolet must also be transverse. Ultrasound are specific sound waves at frequencies higher than human hearing. As sound waves are longitudinal, ultrasound is also longitudinal. Ripples on the surface of a pond go up and down whilst the whole wave moves outwards, perpendicular to the ripples. This makes them a transverse wave. Vibrations of a guitar string consist of a wave moving along the string, which when it hits the other end, makes the whole string go up and down, like this. This implies the movement of the molecules, in this case the string, is perpendicular to the direction of the wave motion, along the string. Therefore, this is a transverse wave. Make sure you recognize the name of all the waves in the electromagnetic spectrum to know that they are transverse. Let's try another example. Microwaves are electromagnetic waves. Describe how microwaves are different from sound waves for 4 marks. We know all electromagnetic waves are transverse, while sound waves are longitudinal. Therefore, this is the first mark. There are inherent differences between transverse and longitudinal waves, such as the movement of particles. The particles in a microwave will oscillate perpendicular to the direction of the wave travel, unlike sound waves, where the particles oscillate parallel to the wave travel. Electromagnetic waves travel at the speed of light. This means microwaves can travel at higher speeds than sound waves. Sound waves travel at 343 meters per second, while microwaves travel at 3 times 10 to the 8 meters per second. And finally, another feature of transverse waves is that they can travel in a vacuum. Sound waves always need a medium to travel through, such as air or water. Let's recap the main differences with longitudinal waves compared to transverse. They are slower. This is because they need a medium to travel in. They tend to have lower frequencies. And finally, the main definition is that particles oscillate parallel to the direction of wave travel instead of perpendicular, like transverse waves. For written answers, make sure you're specific and detailed. Use key terms like vibrates or oscillates instead of moves. In summary, waves come in 2 types, transverse and longitudinal. Particles in transverse wave vibrate perpendicular to the direction of propagation, whilst particles in longitudinal wave vibrate parallel to the direction of propagation. Examples of transverse waves include electromagnetic radiation, which is all the waves in the electromagnetic spectrum, water waves, and seismic S waves, also called secondary waves. Examples of longitudinal waves include, most commonly, sound waves, ultrasound, and seismic P waves, also called primary waves. Longitudinal waves always require a medium to travel through, so they can only travel through solids, liquids, and gases. The waves travel through the particles themselves. On the contrary, transverse waves can travel in a vacuum. This means they can travel a lot faster. Don't forget to check out all our other fantastic revision resources here at Save My Exams.